Well, a lot of people ask themselves, how is the derivative of sine x with respect to dx equals cos x? How? Well, what we're going to do, we're going to prove it right now. But before that, I'd like you to have watched my video on limits. Anywho, you're just going to flow by despite you not watching that video, and let's go on. So what we're going to use when we're getting the derivative, when we're proving the derivative of sine x dx is cos x, we're going to use first principles, which states that the limit as change in x tends to 0 dy dx equals the limit change in x tends to 0 f of x plus a small change in x minus f of x all over change in x. Okay, if this looks new to you, what we're trying to do, we're trying to minimize, okay, change in x tending to 0, we want it to be as small as possible. And f of x plus a small change in x is just f of x plus a small change in x. Basically, it's just that. And now we're trying to see how it relates, how y relates with x, basically. Just like when we have a graph, and the slope of the graph, it's how y changes with x. Okay, enough of that. Now let's get into action. So as of our question, our f of x, which is still our y, is sine x. What about our f of x plus a small change in x? So wherever there was x, we're going to apply x plus a small change in x to obtain sine x plus a small change in x. So using the trigonometric identity that sine a plus b equals sine a cos b plus sine b cos a. That's a trigonometric identity. So from here, we're going to apply that with sine x plus a small change in x to obtain sine x cos change in x plus sine change in x cos x. So with that, we're going to substitute everything into our first principles, and due to space, I'm just going to start where the equal sign was. So the limit as change in x tends to 0 of f of x plus a small change in x, which is sine x plus a small change in x, which is equals to this. So it will be sine x cos change in x plus sine change in x cos x. That's our f of x plus change in x. Then minus f of x, which is sine x all over change in x. Wow, what do we realize? We have a sine x here and we have a sine x here. So what we're going to do, we're just going to bring the like terms together. So the limit, do not forget to write the limit, because most people do and eventually they forget to apply it, which we wouldn't like us to have. So sine x into cos changing x minus 1 plus sine changing x cos x all over changing x. So what we just did, we brought the two signs together and the sine x together, and we still had the other term. We didn't put it away. So from here, since we have a plus sign, it's okay for us to write this term under change in x and also this term under change in x. So to obtain, and also something else that we can do, the limit can be subdivided into these two terms because of the plus sign as well. So we'll have the limit as change in x tends to 0 of sine x cos changing x minus 1 all over changing x plus the limit changing x tends to 0 of sine changing x cos x all over changing x. Okay, so the next part is where I had asked us to at least know something about limits, but do not worry if you don't, because you will see another video on limits. So the limit as changing x tends to 0 of cos changing x minus 1 all over changing x is 0. This is proof for that. And also the limit as change in x tends to 0 of sine changing x all over changing x is 1. This is proof of this, so just look at the next video on limits. So applying that in our new equation, we will have, okay, so let's rewrite our new equation, then we apply it. So sine x, the limit as changing x tends to 0 of cos changing x minus 1 all over changing x plus cos x, the limit as changing x tends to 0 of sine changing x all over changing x. So as I said before, okay, the reason as to why we were able to do this, it's because the limit can only apply to one term if two terms are getting multiplied to each other. And we are of course applying it to the term that has the change in x term. So as I had said before, this part, the whole of this part is a 0, and the whole of this part is 1. So as we obtain sine x dot 0 plus cos x dot 1, any number multiplied by a 0 is 0 automatically. So we've been able to prove that the derivative of sine x with respect to dx is of course cos x. Thank you for watching my video.